Today we're going to have a look at lesson 114, which is graphing square root functions. Just one function, not two functions. It's functions. All right. Now, students will graph square root functions. We're going to kind of revisit some concepts today like domain. Y'all listening to me? And range. So let's review what the definition of domain of a function is. What is domain of a function? It's the set of all the x values of the function, right? That's important. This is a concept that is difficult for a lot of students. They just never quite get it. Very important concept for calculus, very important concept for college algebra, getting you ready for calculus. Domain and range is the set of all y values of a function. And again, it's been a while since we've discussed these two things, so we will spend a little bit of time. I don't know why I put functions up there. It's just, again, just one function. Not a functions. All right, so set of all y values is the range of the function, and the set of all x values is the domain of the function. So we're going to talk about that in just a second. All right? So let's make a table. Now they're giving us some nice instructions here. Make a table of y equals 2 times the square root of x plus 1. And then they're telling us to graph it using the table. So let's do that. Y equals 2 times the square root of x plus 1. And by a table, they're talking about our good old handy-dandy t-chart, right? And pick x values and find y values. Pick our domain values and find the y values that go along with it. Now, because we're substituting into a radical, what values make sense for x here? Perfect squares, right? And they have to be what? Why? All right, so if we're talking about the square root of x, immediately we can talk about possible x values, right? If we put a negative number in here, it breaks it. So what's the domain of this function? 0 or larger, right? So the domain of this particular function, and they didn't ask us this, but I'm just trying to get you to think in that direction. The domain here is any value for x greater than 0. Now, or equal to 0. If I wanted to write that in interval notation, that's x is any value from 0 to infinity, including 0, but not, of course, including infinity. So that's the domain. We'll talk about range. Range is a little bit more difficult for this one. So we're going to plug 0 in, and what are we going to get out for y? 1. I'm going to plug, what's my next perfect square? 1, and I'm going to get 3. Next perfect square is 4. Now again, you could use a calculator and get decimal approximations here, but why? 4 would give us 2 times this 5, and let's do one more. 9 would give us 7. Interesting. We've got a pattern going on right here, don't we?
Yes, sir.
If we put 16 in there, what would we get? 9. The next one is 9. So it's an interesting pattern that takes place here. That's coincidental to what we're doing. But let's graph this. All right, so my y-axis, my x-axis. I'm just going to plot these points. 0, 0 is right here. 1, 3 is there.
Wait, 0, 1. Yeah.
Oh, I'm sorry. Totally messed up right out of the blocks. 0, 1 is there. 1, 3 is here. 4, 5 is here. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 7 is there. So we've got this nice little arch shape. Actually kind of looks like half of a parabola, right? Now, I want y'all to think about this. We have been talking about this for a long time, right? Since I first started this class with you, one of the things that I've been trying to correct from you is that the square root of 1 is just 1. Okay? If we put the negative square roots in here also, then we would get some issues, right? We don't have a function. It's spitting out 2 values instead of 1. Well, other values that it would spit out are these. Okay? And that would be the bottom half of the... Actually, that's not right. It would be here, here. Mirror images of these things. So it'll be a little fatter than this. It'll be something like this would be the bottom half of it. But anyway, that's neither here nor there. What I want you to understand is that to have a function, if we put in one value for x, we can only get out how many values for y? One value. So to protect the square root being a function, it can only put out one value. And I know I have harped on that, but there's a million reasons, not literally, there's a lot of reasons mathematically for you to get that right. Okay? Now, let's talk about, before we move on, this is the graph. This is done correctly. Let's talk about what the range of this graph would be. How would you describe the y values that this graph takes on? Y is greater than or equal to 1. Not just the odd numbers, because it takes on all these values in between these odd numbers too. There's an infinite number of y values between this point and that point, an infinite number of y values. Right? So you can't just take the integral values. We want all the values. All right, so good. Well done. Next example. This just says determine the domain. Now we could do that if we graphed it. You could look at a graph maybe on your graphing calculator and determine the domain of this function. But let's determine it algebraically. What gives us a problem here? Remember that the domain of a function is the set of all possible x values. All right, which x values do we have to throw away? Anything that results in a negative value underneath the square root. Okay? So, the radicand, the domain is defined to be the set of all x's. I'm going to throw some notation at you, such that x minus 4 is greater than or equal to 0. Now, if we solve that simple little equation, what do we get? X is greater than or equal to 4. That's our domain. Okay? Y'all all right with that? The domain comes from x minus 4 having to be greater than or equal to 0. The domain actually is x is greater than or equal to 4. Right? Your question is great. Our domain comes from the fact that the radicand has to be what? Positive or 0. Okay? It has to be non-negative. There's the best way to say that. Okay? So that's the domain. This doesn't ask us to it, but we're honor students. So what is the range of this function going to be? What y values? What can y be? Anything greater than or equal to 0. Why? Because the square root is by definition non-negative. Right? Okay, what about this one? It looks a lot more complicated, but we're just kind of determining the domain. We're going to use the same reasoning. What reasoning did we use last time? The 7 is not under the radical. The radicand has to be what? Non-negative, right? Greater than or equal to 0. Now it becomes a really, really easy equation to solve, right? Move the 4 over. It's -4. Multiply by 2. The domain is the set of all x values such that x is greater than or equal to -8. We don't have to do this, but you really need set notation if you did that. What's the interval notation for that?
X.
-8 to, x is an element of this set from -8 to positive infinity. Okay? Y'all got this? So what's the determining factor for domain?
That the radicand has to be greater.
The radicand has to be non-negative, which means greater than or equal to 0. What else have we learned this year that x can't be? Think back. X can't be a value that makes a denominator equal to 0. Okay, so y'all listen to me. When we're considering domains of functions, you already have 2 of the 3 things that you need to know. We can't have 0 in a denominator. Been talking about that all year with restricted values. What's the restricted value for x? Right? Excluded values. Okay, so we can't have a 0 in a denominator, and we can't have a negative number under a square root. Guess what? In mathematics, there's only one other domain rule. The argument of a logarithm can't be negative. But you're not there yet. Okay? That's the only other domain consideration. You'll learn that in Algebra 2. All right. Describe the transformation that's applied to the parent function to form the graph y equals the square root of x minus 3. Now, we haven't talked a whole lot about the parent function for y equals the square root of x. But y equals the square root of x, when x is 0, y is parent function. Y equals the square root of x. X is 0, y is 0. X is 1, y is 1, right? X is 2, x is 4 rather, y is 2. X is 9, way over here, y is 3. So we still get this nice little half of a sideways parabola shape. Now this says what happens if that's y equals the square root of x. What does y equals the square root of x minus 3 look like? It's moved down 3 units, right? Right there at -3. And then it does exactly the same thing. It mirrors this dude. That's probably not exactly right, but you get the point. It moves it down 3 units. We've not done a whole lot of transformations in here, so I probably wouldn't test you on a question like this, but it's something that you could figure out. Again, that's an Algebra 2 thing that you'll dive into a lot deeper. All right, so what does this 3 out here change? The domain or the range? The range, right? Y equals the square root of x and y equals the square root of x minus 3 have the same domain. X has to be greater than or equal to 0. In this one, the range is y is greater than or equal to 0. In this one, the range is y is greater than or equal to -3. All right? Describe the transformation that's applied to this one. What happened here? The domain's going to change, isn't it? So the range isn't different. If we're talking about the transformation, we're talking about the difference between y equals the square root of x and y equals the square root of x plus 2. All right? So the difference here is going to be this domain is x is greater than or equal to 0. What's the domain here? X plus 2 is greater than or equal to 0, which means x is greater than or equal to -2. This transformation that has taken place is that it's shifted left 2 units. All right? Because the domain changes from x is greater than or equal to 0 to x is greater than or equal to negative 2. Y equals the square root of x looks like this. Y equals the square root of x plus 2 looks like this. Shifted left to negative 2. Change the 0, right? Okay? So these are questions of domain and range. We're not going to deal with that one. There may be a few questions here that you struggle with. Yeah, let's go back to that one. Let's talk about it. Let's talk about what the plus 3 is going to do. It changes the range up 3, right? What's this going to do? It changes the domain, right? We need negative x to be greater than or equal to 0, which means x is less than or equal to 0. This one I can only put negative numbers into. Okay, so this shifts it up 3, and this makes it open to the left. The graph looks like, if this is the square root of x, y'all watch, the square root of negative x plus 3, this graph is up 3 and opens this way. Now you could look at this in a graphing calculator and do that too. All right? Homework.